Hello and welcome to the first video for section 3.7 inverse functions. And our learning objectives for this section are to verify inverse functions, to determine the domain and range of an inverse function, and if we need to restrict the domains to make it one-to-one, find and or evaluate the inverse of a function, and use a graph of a one-to-one function to graph its inverse function. All right, so let's get started. All right, what is an inverse function? Well, if f of x equals y, f inverse of x is the inverse function of f of x if for all y, f inverse of y is x. That's a pretty weighty definition, so we're going to do a lot of practice problems. One thing I just want to note is this notation right here with the little -1, that's read f inverse of x. And it's not an exponent, it's just a way of noting the inverse function, so you have to be careful with that. So if I'm talking about two inverse functions, so let's say I have an original function f, and f of 1 is 3, then f inverse of 3 must be equal to 1. Another way to think about this is if the point 1, 3 is on f of x, then the point 3, 1 is on f inverse of x. So let's practice finding inverse functions from a set. Here is a function defined as a set. If we wanted to find the inverse function, f inverse of x, as a set, what we would have to do is we would have to switch all the x and y's. Remember, if 1, 3 is on f of x, then 3, 1 is on f inverse. So the first point, 0, 1 for f would be 1, 0 for f inverse. 2, -3 for f would be -3, 2, 9, 4, and -4, 12. So if an input leads to an output on f, that input on f inverse leads to that original output, or something like that. Hopefully that makes sense. All right, let's try it from a graph. Here's a graph of the function p of g. Let's see if we can figure out what p inverse of 3 would be. Well, the first thing let's do is let's actually find p of 3. Because that's our first attempt. What is p of 3 equal to? Well, if we go to 3, p of 3 looks to be about, I don't know, 3.5. So that's not going to be our point because for our inverse function, we need to find where y is equal to 3. And we need to find the x value that gives y equal to 3. Three input gives an output of 3.5. That's not what we're looking for. We want to find the y value of 3. So that's about right here. Well, if we do, oops, that's a terrible line. Let's try that again. If we trace along, we see that the input that gives a y value of 3 is 2. So 2, 3 is on the function pg. So 3, 2 is on p inverse. That means p of 3 is equal to 2. All right, let's try the next one. We need to find the input that has an output of -1. So here's -1 value right about there. Trace along. I'm going this way this time because I saw it over here. And we can see that an input of -1 gives an output of -1 on the function p of g. So that's easy swap. That means that p inverse of -1 is also -1. One more. This one might be a little bit trickier. We want to know, let's go ahead and erase these drawings so we can get in there. This says, what x value has a y value of -2 on the inverse? Well, remember, we're looking for the inverse function, p inverse. We don't know the x, that's what we're looking for, the g, and we know the output is -2. So that means on p, the input would be -2. Input of -2 gives the output of -4. So that means p of -2 equals -4, and so p inverse of -4 equals -2. So you just got to keep track. What's your function going forward? That's your regular function. What's coming backwards? That's your inverse function. All right, what if we tried to find the inverse from an equation? Well, let's just kind of think about how operations work. If our function was 3x, so every input was tripled, what would be the inverse function? Well, let's just think of some points in our original function. If we put 1 in, we would get 3 out, triple it. If we put 2 in, we would get 6 out. If we put 3 in, we'd get 9 out. So our inverse function, f inverse of x, would be like 3 goes to 1, 6 goes to 2, 9 goes to 3, and we'd be taking a third each time. So I think we could guess that our inverse function might be, not negative, sorry, 1/3 x. If the function is multiply it by 3, the inverse is divided by 3. So things to think about: what undoes adding 2? Well, that would be subtracting 2. What undoes multiplying by 2? Dividing by 2. And what undoes raising to a power of 2? And that would be square rooting, right? Square rooting undoes raising to a power. All right, so let's try and look at this function and see if we can figure out its inverse. I'm going to teach you a trick how to do it later, but let's just see if we can work through it. Any x we put in here, the first thing we're going to do, let's put in like 1. If we put in 1 for x, we're going to first multiply it by 2 and then subtract 5. That's using our order of operations. So the first thing we did was multiply by 2 times by 2. And the second thing we did was subtract 5. So if we want to undo that, the first thing in the function, inverse function we would have to do is we would need to add 5. That's the first thing. And the second thing we would have to do would be divide by 2. So our inverse function would be x plus 5 divided by 2. Right? We want to undo what we did with the function. We multiplied by 2 and subtracted 5. So to back up, we add 5 and divide by 2. Luckily, there's a nice slick little algorithm that you can use to help find inverse functions. So here are the 3 steps in the algorithm. Step 1 is just to switch the input and output variables. So if we're using x's and y's, I write all the x's as y's and the y's as x's. Then you solve for the output variable. So solve for y and then change it to inverse notation. And I'll do an example right now. So here's our function that we're going to find the inverse of. So the first thing we're going to do is we're going to not write f of x equals 2x cubed plus 1. We're going to write y equals 2x cubed plus 1. Now we're going to switch x and y's. So I'm going to write x equals 2y cubed plus 1. So this was, write y instead of f of x. 2, we just swap the x's and y's. And step 3 is just now solve for y. Now, if you have different variables, you have to be a little more careful, but I think it's easier if we just try it with x and y's first. So to solve this for y, we need to first subtract 1. That gives me x minus 1 equals 2y cubed. Now I need to divide by 2. I have x minus 1 over 2 equals y cubed. How do I undo a cube? Well, I take a cube root or I take it to the 1/3 power, however you want to remember that from your exponent rules. So I'm just going to write a cube root of each side. Cube root cancels a cube and I get y equals the cube root of x minus 1 over 2. And then the last step is, I'm going kind of sideways on it. The last step is to rewrite using function notation. And that simply means replacing the y with f inverse of x. So let's work down here, replace y with f inverse, just to be consistent with function notation. So let's recap that first. I wrote y equals instead of f of x equals. Then I switched the x's and y's and solved for y, and then I replaced the y with f inverse to stick with function notation. All right, let's think about this for a section. Now, one thing it's important to notice is that not all functions have inverses. And not all inverses have functions. So let's look at an example of one that doesn't have an inverse. Let's look at f of t equals t squared. And let's just graph this because I like to think about things graphically. Here's f of t equal to t squared. And let's look at f of negative 2 and f of positive 2. And if we take 2 and we put it into f of t equals t squared, we get 4. And if we put negative 2 into f of t equals t squared, we also get 4. That's what squaring does for us, right? So the point 2, 4 is in f of t, and the point negative 2, 4 is in f of t. So if we flip these, what do we take 4 to? Do we take it to 2 or do we take it to negative 2? And that's a problem, right? So this function does not have an inverse. What kind of functions are we interested in? Well, the key is we need the function to pass the horizontal line test. And remember what type of functions pass the horizontal line test? We need that no output corresponds to two different inputs. So we talked about these type of functions once before. These are one-to-one functions that we need. One-to-one functions have inverses. And remember, they pass the horizontal line test. The vertical line test was just for functions in general. This is the horizontal line test. And that means if you pass the horizontal line test, you can't draw a horizontal line that touches the graph in two places. So you can't have, that means if you do not pass, you have two inputs that go to the same output. Well, we can't have that for an inverse function because we don't know what to map that output to. Do we map it to 2 or do we map it to -2? So you have to have one-to-one functions to have inverses. However, that being said, if we want to force it, we can by restricting the function. So we're not going to use all of t squared. We're going to say, okay, this is a problem, right? This function is not one-to-one. But if we only look at like the left half of this function, let's just take over here, and we just look at this piece of the function, well, now that piece of the function is one-to-one if we only look at the right half, this half of the function. So this is the function f of t equals t squared, but our domain is going to be the interval from 0 to infinity instead of the whole interval -infinity to infinity like it usually is for t squared. So if we look at this restricted domain, what is our new range? And this little subscript is what we use for restricted. Well, looking at this graph, we can see the range goes from 0 as my smallest output value to infinity, which is my largest output value. All right, so if we try to do this one, let's go ahead. It kind of gives you the hint down here that what the inverse function is going to be. But now that we have our domain restricted from only 0 to infinity and range from 0 to infinity, let's do our little trick for finding the inverse function. So we're first going to write y equals t squared. Then we're going to switch the input and output variables, so t equals y squared. Then we're going to solve for y. Well, how do we undo squaring? We square root. So we get y equals square root of t. We're going to pick the positive one, so we get a function. And the square root of t, let's draw that in a different color on my graph here, looks like this. And its domain is 0 to infinity, inclusive. And its range is 0 to infinity, inclusive. All right, so not all functions have inverses. They have to be one-to-one to have an inverse. If they aren't one-to-one, you can force it to be one-to-one by only choosing a domain that has one-to-one, the one-to-one aspect. All right, go to the next video to learn a little bit more about inverse functions.